Okie dokie, today we are doing 15.1, which is how to evaluate logarithms. So before we can evaluate the logarithms, I just wanted to go over why we need logarithms in math and the definition of a logarithm. So I'm going to start with this right here. If I gave you the question, 3 to what power equals 9, most of you would go, oh, that's easy, x equals 2, because 3 squared makes 9. And then if I went 3 to what power equals 27, you're like, oh, totally good with that one too. X has to be 3, because when you do 3 times 3 times 3, you get 27. And then I ask you 3 to what power equals 1, and you're like, you can't trick me, because anything to the 0 power equals 1, so that's 0. But what happens when I ask you what 3 to what power equals 25? So do you realize that this is not going to make a whole number? Now we do know that the exponent is somewhere between 2 and 3. And how do we know that? Because the value is 9 here and the value is 27 here. So we have a value of 25, which is between 9 and 27, so that must mean that our exponent should be between 2 and 3. So when mathematicians stumbled across this a long time ago and they wanted to solve for an exponent, they had to come up with another form, another operation in math, so they came up with a logarithm. So again, this is just how to undo an exponential. It's just an inverse operation. But the tricky part is they chose to use a word instead of a symbol. So the way that we would actually undo this right here is we would do log base 3. So the bases are still the same whether you're in exponential or log form. And then of 25 equals x. So they could plug this into a calculator. Well, they couldn't back then, but we can now. So we can actually figure out exactly what that exponent will be, and we will be doing that in a little bit. So let's go ahead and take a look at this. We have log form and exponential form, okay? So notice here on exponential form, we have b as the base. It's right there. And guess what? In log form, that's also the base. Okay, the b is the base. And then we have this letter y right here is called the argument, not like where they're yelling at each other argument, just it's a math vocab word. You can look it up if you want. And this is right here, the exponent. So one thing that I want you to get stuck in your brain is that logarithms equal exponents, okay? Their whole purpose is for us to figure out what the exponent is. Okay, so they're the inverse of the exponential. So here we have the exponent, and when it's in exponential form, the argument becomes the value, right? You're solving for it that way. That would be the way that it translates. So in the first example, we're just asking you to translate it from log form to exponential form. That's it. So this is the way that you're going to do it. First of all, practice saying this, log base 3 of 81 equals 4. It's not log 381. So again, it's log base 3 of 81 equals 4. So the base is 3, so I'm going to make that a big base, because in exponential it goes from a baby base in log form to a big base in exponential. And then logarithms always equal the exponent, so that 4 is the exponent, and then the argument is the last thing that we're going to write. So we're still using those same 3 numbers, we're just converting it to this form. So again, the base is 2, it becomes big, then we swing over, and because logarithms equal exponents, we get the 3 as the exponent and then 8. Now we're going the other way. We can see these are in exponential form and not in log form. How do we know they're not in log form? Because they literally don't say the word log. It's super simple. So it says rewrite it in logarithmic form. Okay, so we start with log. What's the base of the logarithm? It's the same base of the exponential, but we write it small. Logarithms always equal the exponent, so the exponent is 3, so it's going to be a regular size 3, and then 125. Log, the base is 2, the exponent is 5, so the argument has to be 32. So this is read log base 2 of 32 equals 5.